All right, what we're going to do is add a menu bar to this file chooser demo. And all this does is this opens up a file and it will display it in the text area. That's all it's going to do. And the way that it currently works is pretty minimal. You know, we have an open file button, which brings up this file chooser. And from that, we can either cancel, which does nothing, or we open a file and we can open another one. And then what we added were these scroll bars that automatically appear to allow us to see the entire thing that we've opened. And then again, exit. We can either exit from the button or we can exit from this little red thing here. And one obscure feature that's not on Macs but is actually on Windows. Typically in Windows, one way to close a frame is the red X, which is in the upper right corner. But in Windows applications in the upper left, they will typically have a little icon. If you double click that icon, that will also close the window. For some reason, that's one of the forgotten things for some reason. I don't know. Or did you know that? See, you learn all the kinds of things. All right. So what I'm going to do, just because the menu stuff is its own thing, let's create a separate, helper method. Let's just call it init menu bar. And now the thing is that for these menu items, the main thing is is how they interact with these action listeners. And so there isn't necessarily any need to make them instance variables. In other words, so the outermost item is called a JMenuBar. And since we are a subclass of JFrame, JFrame has a method called setJMenuBar, which tells you that JMenuBar is an instance variable of JPanel, because we haven't defined that method here. It follows the convention of the setter method. And so that tells you that there's an instance variable called JMenuBar, and probably before it is set, it is probably just a null. So if we don't set, notice that everything we've been running does not have a menu bar. So if it's null, then it just doesn't put it up there. So there's probably some code that says if it's null, don't try to show it. But if we have one, and let's see, let's just sort of see we've created it, we've added it, and what does that do? It doesn't do a whole heck of a lot because there's nothing in it. Okay, so that's good to know. But you will notice that this looks a little bit different. So something is happening. Here's how we add stuff to it. We add it with a JMenu. And traditionally, the one on the upper left is called file. You can see that here. So let's create a menu. We'll call it a file menu. And what we do is we add it to our JMenuBar. So this is and what the menu bar does is it will lay out the different menus in the order that we add them. And there's a way, I think add is overloaded, so there's actually a way to add a menu at a particular index. And it's this silly zero-based indexing stuff, so, but, all right, so we now have a menu in our file menu, and now we see that it appears. So there it is, and doesn't do anything. Now what we expect when we see something like this is to click on it and that we see a little drop-down menu. That's what we expect. We're not seeing that. Why? Because we haven't done it. Actually, in the old days, I believe it was one of the Sun Microsystems operating systems, they had a situation that was actually very disconcerting because they would have menus, and sometimes when you click on a menu, a menu would pop down, but sometimes it would actually do something when you clicked on it, and it wasn't clear which was which, and that was not a good thing. Nobody does that anymore, as far as I know, and Sun Microsystems went out of business a few years ago and sold everything to Oracle, which had nothing to do, I think, with what they did with their buttons, but that's just saying. Okay, so we see what that does, and now, all right, so what do we have? We have two tasks here. We have one task which is to open the file. So the way we add items to the J menu is through a J menu item. And let's call it a open file. So basically what we're doing is we're going to be offering the user of this fabulous application the opportunity to either click on a button to perform the task or to do it via the menu. So we're giving them the option. Sometimes options are a good thing. All right, so here's the menu item. We're going to call it open file, and we're going to add it now to not to the menu bar, but to the file menu. So we say file menu, add open file item. So now we have, now when I click on the file menu, I now get the item that I just put there. Okay? And now, okay, there's sort of truth in advertising. So I have a button here that says open file. I have a menu item that says open file. And when I click on the button, it opens a little file chooser. And when I click on the open file button, it does nothing. Okay, so that's not a very user-friendly thing. If you have two places that, even just one place that promises to do something, if I have something that says, if you click here and I'll open a file, and I click there and it does nothing, then you do what we always do, which is you click harder and you click lots of times and maybe one will work. Or, in this case, since we're building it, we'll put the functionality in. Well, so let's, the other task is to exit. And let's add that just to be says file menu. Okay, so now we have two items, so that when where did it go? We have two items, and now when we click file, we see we have two items that don't do anything. Again, exit promise to exit, it doesn't do it. So how do we, oh, and just one little bit of eye candy. Notice that typically when we click on something that has a number of different tasks, the tasks are kind of grouped by their commonality. In other words, here we have two things that say new project, so the new stuff is in one group, and then we have a little line here, and then we have a bunch of stuff that's kind of opening and closing, and then other things. So how we can do that by something on the J menu called a separator. We can add a separator. And what that separator does is it just draws a little line between the different items. So here we only have 2 items, so it's not terribly necessary. But as you can see, there's now a little line that separates the two. And even in this case, you can make a case for this because the task of opening a file and the task of exiting the program are very, very different tasks. So we will want to separate them in some way. Okay, so that's how we add a menu. And if we wanted to add another menu, we would simply do the same type of thing. But the question now is, okay, we've added the menus, and it's kind of now it's working at least the way we kind of expect. That is, we click on it, and now we see a list of menu items that we can choose from, but they're not live. They don't do anything. So how do we make them live? Well, how do we make the buttons live? We made the buttons live by having them listen to an action listener. So our exit button was listening to this window closer thing, and that window closer class was what had the, and in this case we kind of moved it out of the of that class because this is a reusable component. In other words, an instance of this class will do the same thing for lots of different applications. Anytime you need that functionality of either responding to a button or to trying to close a window, it'll throw up a little confirm dialog, are you sure you want to do this? So that's one nice thing. So that's how we did the exit. So and notice that, remember the discussion about scope. The principle of minimum scope is that the scope of your variable should be as small as possible, but no smaller. So in this case, we could have made the window closer have less scope. Like within a class, an instance variable is really the maximum scope that you can have for that instance, because every method has access to that. Whereas a local variable in a method only has access within that method, and not only that, it only has access within a specific call of that method. Every time you call the method, that local variable gets reinitialized. So the local variable goes away when you return from the method. But in this case, we created an instance variable, again, without comment. But here's one of the reasons why that can be a valuable thing, even though the scope of this variable is perhaps a little broader than we might want at first. And having defined this instance variable, again, let's look at our exit button. What do we want for our exit button? We want it to act exactly the same as either closing the window with the red button or clicking on the exit button that we had already created. We want exactly the same result. And the only way to 100% guarantee exactly the same result is to run exactly the same code. And in this case, it will be to use exactly the same window listener for our exit menu item. And the thing about these exit menu items is that they're actually they're a subclass of the J button. So it is a button, and it's actually something that responds to these action listener thing. So we can add an action listener. We add the window closer action listener to this exit menu item, and this fills the or meets the programming virtue of laziness in several ways. One is we're implementing this task of confirming with the user exactly once. And further, we're not only, now we actually could create another instance of this, and that would provide more or less the same thing. We're go even further. We're using literally the same object. In other words, this object, this instance variable that's a type of window closer, that exact object is responding both to the exit menu item and to the exit menu button. Both of them. So now, again, when we click on exit, we get the confirm. We click on the red thing here, we get the confirm. Now when we click on the exit, we get the confirm. And that's guaranteed to be exactly the same and work exactly the same way, regardless. So, and what have we done? We have used what we had already done, which was nothing more than instantiate one of these window closer things. And with one line of code, we have added functionality that was guaranteed to be exactly the same. Now, I mean, you say, well, that's obvious. Well, it's even if you eschew, let's see, let me open, so we want to do the same thing with our open file item, which is we want it to do exactly the same thing as open file. What does open file do? It opens up a file dialog, and then when we choose it, remember in a separate thread, it was reading in this file. Again, for a small file like this, it's a very small thing. As many of you probably noticed in the previous exercise, that kind of downloading and unzipping that large movie database file took a few minutes. So that's another example of where running it in a different thread is something that you generally want to do unless you don't want to lock up your application for the whole time. In that particular case, it was less of an issue because we weren't doing anything else with that task, and it wasn't a visual task either. But nevertheless, it's a good practice whenever there's a long-running task that you want to keep it off the graphics thread, because otherwise it locks up. The only time you want to lock up your application is when you're doing something that you don't want anything to proceed until the user does something. So here we're saying, do you really want to exit? And so there's no point in anything from the user until they decide this. This is what's called a modal dialog, and it does lock up the application, and that's by design. Similarly, when we open the file, again, there's no point in doing anything else with regard to the user until the user makes his choice here. So everything else is locked up. However, if in this particular case we were doing some other task in a thread, that would continue because that's not on the graphics thread. Okay, so so what is it going to take to add again, let's see what is going on. So we have we have this working, and the open file is still not implemented. So let's, because we have an instance variable called open file action that is one of these open file guys, we can the open file item, we add the action listener, not the window closer, the open file action. Okay, so that open file action, that was an instance of this inner class, and that implemented both the action listener. Now, so what are the different tasks of these two interfaces? The task of the action listener interface is to respond to the user's request, the user clicking on the button. So that's what the action performed method is responsible for, responding to what the user is clicking. In this particular case, we're then going to say, do you want to choose a file? And if they decide to choose a file, then what we do is the runnable interface is responsible actually performing that potentially more lengthy task. Okay, but all of that is triggered by the action listener in this particular case. So what we should have now what we're looking for is a situation where when we click on this, we get exactly the same response, and it works exactly the same way. That when we open a file, we can even, let's see, we can even open, here's, okay, so that was the, okay, so the lesson here is that the most effective way to have the same task performed by different widgets is to make sure that the same code gets executed. The most reliable way of doing that is to make sure that you're using exactly the same objects for this. The way that Swing works is by having these action listener instances so that the action performed method gets called whenever you click on that thing that you're manipulating. Okay, so now we can put these menus up and do some other things. Now there's one thing that I think I kind of promised that I never got to. Where is it here? And that is, this is less visible on Macs because the way that the Java Virtual Machine is implemented, the graphics on a Mac, they seem to look a little more like what a Mac application does. On Windows, what they've, or at least my experience, and yours may vary, is that the frames, the J-frames actually look pretty good in terms of looking like other window things, but the file choosers kind of look, in my view, a little disconcerting. If you're running a Windows application, then you want it to kind of look like a Windows application. And I say that as a Mac guy. I mean, I'm not prejudiced, I think. I try not to be. So how can we deal with that? Well, there is a thing called a look and feel. And here's how we can, there's a way to set your program, and I think this is kind of nice, so that it will have roughly the same look and feel of whatever platform you're running it on. In other words, one of the many reasons to program in Java is that the same program will run on all the major operating systems without modification. The problem is that they will, by default, they will use this sort of Java look and feel, which is kind of generic and a little ugly. What I feel most people want is they want something that kind of looks a little normal. So here's the magic code for that. there's something called the UA Manager, and it has a method called set look and feel. Now, if you can actually roll your own if you have enough knowledge about this. But here's the magic. The magic incantation is that the UA Manager also has a here we go. Get system look and feel class name. Returns the name of the look and feel class that implements the native system look and feel. If there is one, otherwise then, so if there is one, it will, whether there is one or not is actually a function of the implementation of the Java virtual machine for that platform. The ones for Mac and Windows, are, especially the Windows ones, have been always pretty consistent. And it's throwing some exceptions. Let's surround the statement with a try-catch thing here and there. So they could have done this a little bit better, in my opinion, but that's neither here nor there. Rather, for example, no. Now there's not, we haven't really talked a lot about these exceptions. There is something called, they did add a thing called multi-catch. So rather than all this garbage here, we can kind of make them all into this one thing. NetBeans does this sort of logger business. We haven't talked about loggers. Logging, again, if you're developing major stuff, then that can be an issue. I've actually found that a third-party logger, the Apache Log4j, is actually a bit nicer than the one built into Java, so that's the one I typically use. But again, that's for what we do and probably for what you will do in the near future for whatever programming you do. If you do programming in Java, then it's less of an issue. Anyway, so what this incantation will do is this will have the same code run and look more or less like whatever platform you're running on. In this particular case, it doesn't change things that much. So as you can see, it hasn't really done a whole lot, but on Windows, it should make a difference. Anyway, so that's that. Okay, so that's really all I have